Hello, pre-calc students. Let's take a look at section 5.5, which is our last section before spring break. And this is a quick section, but I just want to get into a little bit of the right triangle trigonometry that we talked about a little bit yesterday in class, and just remind you what all of these things mean and how they relate to what we've been doing. So I'm looking at the notes for section 5.5. At the top it says trigonometry means, I think I mentioned this once before, but it literally means triangle measurement. In case you're interested, a little piece of trivia there for you. And so everything's really based on a triangle of some sort. And we're going to look at right triangles today. So it says name the 6 trig functions along with their abbreviations. Just to recap, we've already talked about these, but here they are again. The first one is cosine. Abbreviation for it is COS, cosine of theta. Sine, of course, in the abbreviation is SIN, sine of theta. And then the last one there is tangent. And of course, the abbreviation is tan of theta. And then the 3 reciprocal functions, make sure you know what is the reciprocal for what. So cosine, the reciprocal is the secant function. The abbreviation is SEC. Sine, the reciprocal is the cosecant function. Here it is in words. Abbreviation is CSC. And then, of course, reciprocal for tangent is cotangent. And the abbreviation is just COT of theta. All right, so when we talk about a triangle, talk about these in terms of a triangle. So we're kind of going to get away from the X's and the Y's and the R's we've been talking about. And I'm probably going to use triangles most of the time from here out because I think they're a little bit more intuitive than using the formulas we've been using so far. So let's talk about a right triangle, and theta would be one of the acute angles. It could really be either acute angle, but generally I label it the angle that's down here. Of course, we have our right angle. We know the hypotenuse is always across from the right angle. The side across from theta, the angle we're working with, we call that the opposite side. And then the side that's next to theta, that's obviously not the hypotenuse, we call that the adjacent side. I'm going to use ADG for abbreviation, adjacent. All right, so how do we define these 6 trig functions in terms of the triangle? So you probably remember this from high school, the little acronym SOHCAHTOA. Kind of a rite of passage. I learned it in high school. You probably did too, and here it is again. I just think it's kind of a tried and true way of remembering what goes with what. You just got to make sure you spell it correctly. That's the trick. So sine theta, of course, is equal to the opposite side over the hypotenuse. Cosine theta is equal to the adjacent side over the hypotenuse. And then tangent theta is equal to the opposite side over the adjacent. Okay? And then the other 3 fall directly from these, as long as you remember what is the reciprocal for what. Sorry, my cat is, I don't know if you saw that or not. My cat's pushing on my mouse here. So let's try that again. The other 3 are the reciprocal functions for the original. So as long as you remember what goes with what, as long as you know SOHCAHTOA, then the others you can just figure out as you need them. So for example, cosecant is the reciprocal of sine. So that means that cosecant, back here, cosecant is going to be the hypotenuse over the opposite. Oh, my pen stopped writing. Hold on. Okay, sorry about that. Let's try that again. So cosecant, we said, was the reciprocal of sine. So that means cosecant is going to be the hypotenuse over the opposite. Secant is the reciprocal of cosine, so that's going to be the hypotenuse over the adjacent. And then cotangent, of course, is the reciprocal of tangent, so that's going to be the adjacent over the opposite. Okay? All right, so let's look at the example here. It says evaluate trig functions, find the value of each of the 6 trig functions of theta in this figure. Now, they didn't label theta, and they really should have. So when you see a question like this, theta will be labeled. I assume they would have used this angle down here. So let's go ahead and pretend that was theta. The only thing we don't have is the hypotenuse. So we need to use Pythagorean theorem to figure out the hypotenuse. And I'm going to forgo the details here. This is a Pythagorean triple. It's actually one we did in class yesterday. So C would be 13. So the hypotenuse here is 13. So going from there, we can go through our 6 functions. The order you do them in doesn't matter. If we follow SOHCAHTOA, we'll do sine first. Sine would be opposite over hypotenuse. So if theta is here, sine would be 5 over 13. Cosine theta would be the adjacent over the hypotenuse, so it'll be 12 over 13. And then tangent, of course, will be the opposite over the adjacent, so 5 over 12. And then the reciprocals, cosecant, of course, would be the reciprocal of sine, so that would be 13 over 5. Secant is the reciprocal of cosine, which is 12 over 13. And then cotangent is the reciprocal of tangent, which makes it 12 over 5. All right. Question 2 says solve the right triangle ABC if angle A is 23 degrees and side C is 5.8. Generally, we use capital letters for angles and lowercase letters for sides, just as an indication, but you can also see 23 degrees, that's in degrees, so that has to be the angle. So draw a picture before you do anything else. I'm going to go ahead and draw my triangle this way. And I'm going to put my hypotenuse here. Let's call this angle A. We'll call this angle B, and we'll call this angle C. You can switch the letters. It doesn't make a huge difference, but angle A we do know has to be 23 degrees. So wherever you labeled that, make that 23 degrees. Side C would be the side across from angle C, so that means this has to be 5.8. When it says solve the triangle, that means they want you to find all the missing sides and angles. The order you do this in doesn't really matter, but you want to kind of do it in a way that makes it easiest for you. I would start with angle B. So remember that angle B, the measure of angle B, the angles in a triangle have to add up to 180 degrees. Remember that from high school geometry. So if this angle C is 90, angle A is 23, I can find angle B by finding the difference from 180. Let me get my calculator out here. So I've got 180 minus the 90 for the angle C, and then minus the 23 leaves me a difference of 67 degrees. So that means that angle B is 67 degrees. Now get your calculators out because these are not unit circle values. So to find the rest of these, I'm going to have to use the buttons in my calculator. Remember yesterday we talked about how to evaluate some of these trig functions in our calculator, and that's what we're going to do here. To get the other two sides, I can't use Pythagorean theorem because I only know one side. Remember, to use Pythagorean theorem, you have to know two sides of the right triangle. So we're going to use one of our new trig ratios. Does not matter which one you use exactly, as long as you're setting the ratios up correctly. However, I would stick to the one that involves angle A, because in case we made a mistake calculating angle B, you don't want to use it again to do another calculation. So if I use angle A, and let's say I wanted to find angle B, side B first, then to find side B, which trig function would that involve? All right, which trig function would that involve? Side B is the adjacent side to angle A, right? Side B is the adjacent side. Fill that in again. Side B is the adjacent side to angle A, and we know side C is the hypotenuse. So think about the adjacent over the hypotenuse. If I want to involve that ratio, that would be your cosine function, wouldn't it? So that means the cosine of angle B, cosine of angle A would be the adjacent side over the hypotenuse to angle A. So let's write that down. Let's fill in what we know. The cosine of angle A was 23 degrees, and the adjacent side is the unknown, that's B, and the hypotenuse is 5.8. So what I have here is a little equation I can solve for B. I'm going to multiply both sides by 5.8 to get B by itself. So then in my calculator, I'm going to do cosine of 23 degrees times 5.8. So let's get the calculator out. And I'm going to do, it doesn't matter the order you do these in. I have to do the angle first in the calculator on the computer. So I'm going to do 23. And again, make sure you're in degree mode. And I think I am. Let's see. Yes, I'm in degree mode. So I'm going to do 23. Let's see, 23. The cosine of that, so there it is, the cosine of 23 degrees times the 5.8 gives me a value of 5.3389, so about 5.3. So that means that side B is equal to 5.3. And that should make sense because if 5.8 is the hypotenuse, that side should be shorter than that. If it were bigger than 5.8, we'd kind of question it. So far, here's what we've got. We've got angle B with 67 degrees. Side B is 5.3. Now, I still need to find side A. Little a is across from angle A. We could use Pythagorean theorem to do it at this point because I know two of the sides, but we could also use trigonometry to do it as well. Just for practice, let's just use the trigonometry function using angle A and side A and the hypotenuse of 5.8. So that would be, since side A is opposite over hypotenuse, that would be sine. So that means the sine of 23 degrees would be A over 5.8. So I'm going to basically do what I just did, just using the sine function. I'm solving for side A, multiply both sides by 5.8. So in the calculator, again, I'm going to do the trig function first. I'm going to do 23 degrees, take the sine of that, and then I'm going to multiply it by the 5.8, and that gives me a value of looks like about 2.3. So side A is approximately equal to 2.3 units. Okay, and again, we could have used Pythagorean theorem for that as well. We would have gotten the same result. The ratio of those sides should make sense. Side A is across from the smallest angle, so it is the smallest side. Side B is the next bigger angles, across from the next bigger angles, and it is 5.3, the next larger side. And then, of course, the largest side is across from the hypotenuse. So I think we're okay there. Number 3 is very similar. Solve the right triangle, and this time they're giving you two sides. All right, so let's draw our picture. We're going to label the sides again. I'm going to call this B again. I'll call this A, and we'll make C our hypotenuse. So side A is 9.5, side B is 3.4, and the hypotenuse I don't know. We can go ahead and find the hypotenuse using Pythagorean theorem. We don't need to use any trigonometry here. So if I do that, I've got 9.5 squared plus 3.5 squared equals C squared. So let's get our calculator out here. And we've got 9.5 squared plus 3.4 squared equals, and then we want to take the square root of that. So I'm getting a square root of about 10.09. So we're going to say, let's see, C is equal to, I'm going to just round it and make it 10.1, so they all just have one decimal. So side C is about 10.1. All right, now, the next thing we need to do is get angle A and angle B, and here's where the trigonometry comes in. Now, it doesn't matter which one we do first. If we start with angle A, just to do that one first, then think about which sides you want to use to work with angle A. You've got some options here. We can stick with opposite over adjacent, and those were the ones that were given to us. That would involve the tangent function. We could use the hypotenuse that we just computed, but again, I don't like to use something that I just computed to do a new calculation in case I messed up. I don't want to use that in a new calculation. So why don't we stick to the two sides they gave us, which are the opposite and the adjacent side. So that means we'd be using tangent. So I'm going to set up a little equation, and I'm going to say the tangent of A, because I don't know what A is this time, is going to be the opposite side over the hypotenuse. And you may remember in class yesterday, I mentioned this just very briefly. I said, if we're looking for an angle, that's when we use the inverse button in our calculator. Remember, we made a big distinction about the difference between an inverse and a reciprocal. Those are different when you're talking about trigonometric functions. And so the inverse button in our calculator is what we're going to need to use to figure this out. So I'm going to go ahead and let me just write algebraically kind of what we're doing. You can think of it algebraically as taking the inverse, just like an inverse function we talked about earlier in the course, taking the inverse. Sorry, it's a little bit messy here, both sides. And the inverse, remember, undoes the original function. So on the left side, the inverse tangent of tangent just leaves me with angle A, and that's what I want. On the right side, we've got inverse tangent of 9.5 divided by 3.4, and that's what we're going to put into our calculator. So anytime you're looking for an angle, you're going to use that inverse key in your calculator. So I'm going to do, let's see, I'm going to do 9.5 divided by 3.4 first. And then in my calculator, I'm going to use, I've got to do this little second key. But on your calculator, I talked to you about a little bit yesterday in class. Make sure you know where that inverse button is. It's going to look like this, little tan with a -1. Click on that. And notice I was in degree mode, so it gives me an angle of about 70 degrees, which sounds about right, 70-degree angle. So I'm going to just say, let's see, it was 70.3. I'm just going to make it 70 just for simplicity. I'm going to round it to the nearest whole number. So we'll say 70 degrees. All right. Now, to get angle B, we could do another trig ratio. We could also just say they add up to 180, just like we did earlier. So angle B, of course, would be 180. Measure of angle B would be 180 minus the 90 that we already have and the 70 we just came up with. So if we just put that into our calculator, let's see, we're going to have 180 minus 90 minus the 70, of course, leaves us 20 degrees. So angle B is approximately equal to 20 degrees. We'll put angle here. Okay. And again, think about, do the ratios make sense? Angle B was the smallest angle at 20 degrees, and so it's across from the smallest side. Angle A is next at 70 degrees, and then angle C, of course, is the largest because it's the right angle and it's across from the longest side. That's what you would expect. All right, a couple more quick application questions. From an observation deck 425 feet high on the top of a lighthouse, the angle of depression to a ship at sea is 4.2 degrees. How many feet is the ship from a point at sea level directly below the observation deck? So it's kind of hard to explain on video what I mean by an angle of depression. You can Google it and get an idea, but basically the angle of depression, all right, pretend that's a horizontal line. Let me try that again. That's not very straight. Let's draw that again. So if you think about a horizontal line, it's a little better. If you think about it kind of like your line of sight, right? So like if these are my eyes and I'm looking out, my angle of depression is made from the horizontal line of sight downwards. It always goes this way, right? So an angle of depression would look like this. You can also have something called an angle of elevation. So this would be your angle of depression going down. You can also have something called an angle of elevation, where it's measured from your line of sight, but going upwards. I don't leave myself much room here. Let me draw that again. So if this were my line of sight this time, then my angle of elevation would be measured from the line of sight upwards. So that would be your angle of elevation, something like that. So on a question like this, you always want to draw a picture and get a sense of what the heck it is they're talking about. So from an observation deck 425 feet high on the top of a lighthouse. So let's just I'm not going to worry about the height of the lighthouse. I'm just going to assume the vertical height they're talking about is 425 feet. All right, so you're at the top here. Your line of sight, you got to think, would be like the horizontal would go out this way, right? That would be your line of sight. But the angle of depression to a ship at sea. So we'll say, okay, here's our water, here's our sea down here. The ship is maybe out here. The angle of depression would be like this, right? So you're looking downwards at this ship in the water here. That angle of depression is 4.2 degrees. The question says, how many feet is the ship from a point at sea level directly below the observation deck? So the distance they're looking for is how far away is the ship from the bottom of the observation deck. So I'm going to call it X here. This is what they're looking for, right? Is this distance here. This is our right angle. So we've got a right triangle here. What we know is the angle of depression is 4.2 degrees, but within the triangle, there's a couple of different angles I can work with. This angle here is easy to find out because it's the complement of the 4.2 degrees. Remember what a complement is. we'll call this angle A. The complement measure of angle A would be 90 minus the 4.2 degrees, right? So that would be 85.8, right? 85.8 degrees would be this angle right here. The other option is to use this angle down here. And if you remember from high school geometry, this angle would actually be congruent to the angle of depression because you've got two parallel lines cut by a transversal. If you didn't recognize that, it's not serious. You could have used that angle, but you can also use this one up here as long as you see that this is the complement of the angle of depression. I'm going to stick with the 85.8 because I think that one's a little bit easier to use. So think about, all right, this is the angle I want to work with. This side is what I'm interested in, and I know this side is 425. So we're looking at the opposite compared to the adjacent. Which trig function would I be working with? So we'll say that that would be the tangent, right? Tangent of the 85.8 degrees is equal to x divided by 425. And so we're going to solve for x here. We're going to multiply by 425 on both sides. And then in my calculator, we're going to put that information in. Here we go. So I'm going to have, I'm going to do the tangent first. So I'm going to do 85.8. And then we're going to do the tangent of that angle times the 425. And I'm getting a distance of 5,787. All right, and that sounds about right. You're talking about a ship out at sea. It should be pretty far away from that lighthouse, right? So that means that x is approximately, what did I just say? It was 5,700. We'll just round to the nearest whole number for now, 5787. Okay, so just a quick example of how we could use some of this trigonometry to help us solve some application questions. I think I'm going to skip this last question for now. We're not going to do a whole lot of these application questions. I do want to go back and tie this back to what we've been talking about with the unit circle. I think that's probably more important at this point. But just make sure you bring your notes to class tomorrow. We're going to meet, remember, on Zoom, and I'll send you a link with the video information for Zoom for tomorrow.